Okay, hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms. The date is 2025, May 19th, 52 past midnight. So it is well, literally a brand new day. In my last video, I promised that I would be right back just as soon as I fix my mistakes and get the right just as soon as I got the right plots, because they were wrong. I did them wrong, and I had to redo them. So I did that, and to be honest, I also went out for a jog, and about 2 hours later, I'm back. So in this session, this session for very briefly. I'm going to keep the session very brief and short because I am only going to go over the slope plots, the positive slope ratio plots, and then that will be the end of part 2, which is this session. And then the next session, which will be a very long session, I believe, I will be going over the entity distribution plots and the summed utility plots in tandem to once and for all finally decide which combinations or which set of methods or which combinations are among the best. I might pick 3, 5, or even 10 combinations, but for that I need to go over 1848 combinations. I hope that's right. Yeah, that's right. So that's that. Let's quickly go over the positive slope ratio plots. So for the 2025 0506 underscore 1, if you remember, this is the world positive slope ratio plot. And as you see, the positive slope ratio goes up as the learn rate goes up, which is quite obvious. Then again, each learn rate is in different color. So below in this one is each data point is the average of per color. Average of each color or each learn rate. So when we do that, we see that the average positive slope ratio goes up and then plateaus. This we have seen, and next up, this is where I did it wrong. This is for the limited entities. So for the limited entities, apparently in the version before this, I had the variables mixed up and I kept getting the same plots, and I hadn't noticed until I went through like 5 notebooks. So this is the positive slope ratio for the limited entities, and yeah, as you can see, they all go up. The interesting thing is that things really do pick up when the learn rate hits 0.2, when it jumps from 0.1 to 0.2. That is when learn rate is 10%, and then if it changes from 10% to 20%, it really changes. It was this much, and then now it's this much. But if you remember, the positive slope ratio is greatly exaggerated or inflated for the limited entities, because as the learn rate goes up, more entities get struck out and fewer entities get limited, and because there are fewer entities, it is easier to inflate the positive slope ratio for the limited entities, even though there may be the same number of entities with a positive slope. But however, if we move to the struck out entities, and then the statement that things really do pick up when the learn rate changes from 0.1 to 0.2, the change is bigger than when things go from when learn rate goes from 0.0 to 0.1. There's a slight change. However, the change between these two are very, a lot more noticeable. And then anything after 0.3 is just about the same in this case. And this is the average per color. Yep. So this is when we used the universal fixed learn rate and the candidate ranges, all 66 of them. On to the next notebook, which in this case we still use the universal learn rate fixed from 0.0 to 1.0. However, in this notebook, for the candidate method, for the candidacy method, it's proportional tail that is being used, and proportional tail, just as a reminder, is where if this is the world, proportional tail, this is tail, this is head, this is the this graph represents the max is 1, the minimum is close to 0 or 0, and this represents how likely it is for each entity to be picked as a learn candidate. So that the tail entity will most definitely be picked. Well, it's not 100%, but everything is relative in this case. For the candidate methods, everything is relative, unlike the learn rate method, where the learn rate has to be a definitive number between 0 and 1. But in this case, I'm talking about the candidate method. So the tail entity has the highest chance of being picked as a learn candidate. So that's what's happening here. I'm using the proportional tail candidate method in this case. And as you can see, even in same in this case, the positive slope ratio goes up as the learn rate goes up, but it does hit some kind of a plateau after 1, 2, 3, when the learn rate hits 0.2 or 20%. Yep. And then yeah, it still goes up, but it doesn't actually get that much better. For the limited entities, this is still this is very similar to what we have seen in the in this one. Where is it? This one. See, everything is exaggerated or inflated because there are now fewer limited entities. But the and therefore the positive slope ratio goes extremely high, almost at almost at 1.0. See, the highest is 0.99, and I guess that's somewhere about here, maybe, or here. However, for the struck out entities, yeah, I shouldn't have said however, because it's the same here as well. We see a continuous rise on this plot as well, and the point still stands, as in bigger changes happen when learn rate goes from 0.1 to 0.2. It doesn't seem that big here, but it is quite big here. Of course, things have been exaggerated here as well, but if you look here, yeah, things are, all these 9 learn rate results are, they look similar. However, 0.0 and 0.1, they look different. But 0.1 and 0.2, these two look more different than these two. So my point still stands. For when the candidate method is proportional head, this is what happens to the positive slope ratio. Yep. Again, a huge change in between, 0.1 and 0.2. For the limited ratio, something very similar. Again, we've seen this. For the struck out entities, we've seen this. And this is exponential tail, and this is what happens. Okay. Here the difference between 0.0 and 0.1 the difference between the differences between 0.1, 0.0 and 0.1 and 0.1 and 0.2 is less noticeable here in this case. Yeah. And however, we do see a gradual increase here as well. And for the limited entities, but this is still, everything is so much inflated. For the struck out entities, yep, slow increase. Sorry, I was coughing too much, so I had to get some water. So anyway, this is exponential head, the candidate method, and for the wild, again, nothing we haven't seen. Limited, the usual struck out entities, quite usual. This is normal distribution. The candidate method is normal distribution. This is for the world entities. For the limited entities. And for the struck out entities. This is for the random candidate method. So every learned candidate is just chosen at random. Yep, I've seen this. Wait, are these the same? No, they are not. My God. And next on to where learn rate methods are used, as well as the candidate methods. This 0514 is where the learn rate method is a proportional tail, and the candidate method is also proportional tail. And wait, do I have that right? Let's see. Yep, I have that right. Wait, no, I don't have it entirely right. So this notebook 0514_0 is where learn rate methods are used, all 6 of them, and the candidate method is fixed to proportional tail. And in this notebook, the positive slope ratio for the world entities look like this: per color, per learn method, and this is what they look like, average per color. For the limited entities, this is what it looks like. You see the plots are here. They're just intertwined all the way down here, so you really don't see them. See, they're close to 15% or so, maybe 16%. And this is what it looks like for the struck out entities. This is what it looks like. Next up is the same, but the candidate method being used is the proportionate head, and this is what it looks like. This is what it looks like per color, average per color. For the limited entities, almost the same. It's like it looks like a cow, a bull rather. For the struck out entities, see, this is almost identical. No, not that identical, but the overall pattern is the same. So on to the next one, exponential tail, the candidate method. So this is what it looks like. And this is what the averages per color look like. Oops. For the limited entities, and for the struck out entities. So again, quite similar. And this one is where the candidate method being used is exponential head, and this is for the world entities. So slightly different. Actually, almost the same. For the limited entities, almost the same. For the struck out entities, almost the same. Now, this is the normal distribution. The normal kind, normally distributed. And this is for the world entities. Is this the same? I don't know. Oh, it's not that same. It's not the same. Huh. That's cool. This is what it usually looks like for the normal for the world entities, the positive slope ratios. However, for the when the candidate method is normal, follows the normal distribution, or this is what it looks like. It goes back to looking like a bull again. For the limited entities, same. I wonder why. Okay. And for the struck out entities, that's almost the same. For when candidates are chosen at random, this is the normal, this is the world entities. Again, we're back to... No, actually no. No, yeah, we are back to looking like a duck or something. And then for the limited entities, this is what it looks like. For the struck out entities, this is what it looks like. So overall, they do share a very generic, very general pattern, and it's not that easy to say or see what the optimum combination is by just looking at the positive slope ratios, or the lifespans, or the entity counts. Now the real job, the real tedious job is going to happen. It is going to be done in the next part. So thanks for watching. See you in the next one. Bye.